Good morning. My name's Daniel Sassen. I'm Head of Technical Operations at Envy, and I'm very proud to be an ex-Ravensbourne student.
Good morning. My name's Davies. I'm Senior Engineer at Envy, specialising in workflow.
Hi, I'm Dryden. I'm Head of Visual Effects at Envy, and I specialise in CGI and 2D workflow, and 3D now.
So, for those of you that don't know Envy, we're one of the largest independent post houses in London. One of the things that's fairly unique about Envy is that we work with long-form and short-form programming. So, many people will say that the most important thing when shooting stereo is to get a good stereographer on board as early as possible, and to have them involved at the planning or pre-production stages. We agree that this is essential, but would like to emphasise the importance of one extra point. We believe that it's imperative the post house is also involved in these early stage meetings. There are various types of camera rigs that you'll work with. So, there's side-by-side and mirror. And there's not enough time today to go into how each of these and the differences between them in any depth and the whys and wherefores of each. But when it comes to posts, we require a slightly different approach with each of them. One of the problems you're going to have in post is sync. There are two options to record cameras off these rigs. You can either record them file-based, or you could obviously auto videotape. The file-based recording obviously includes solid-state recording or disk-based recording. But the most important thing, as I say, is getting the sync right between the cameras. And to do this, and for best results, left and right pictures will have the same timecode. So this can easily be achieved with formats like the SI2K camera, which has left and right pictures in a file wrapper with one timecode shared as metadata. This can also be achieved with any pair of video cameras that are gen-locked, have video out, and go to a single recording device, like a codec or HD Cam SR dual stream. In this case, the pictures share one timecode. The beauty of going to HD Cam SR in this way as well is the pictures are on one tape in the dual stream mode. Another example of a camera format that's recently become available with a stereoscopic option is the Alexas, and they have very, very tight control over gen-lock. The other important thing with sync that you really need to look into and find out about is whether not only the cameras are gen-locked, but how closely the shutters are synced. So the best people to advise on all of this is actually not the post house, but the production company who are running the shoot. But as always, we're there to help to advise. If sync isn't done properly, then you're going to have a real headache in post. So what to expect in post, I'll hand over to Adam.
Okay, you can see here we're going to talk about Rush's correction. So first off, what needs to be done? What needs to be done really depends on what kind of rig you've shot on. So if you've shot parallel, you're going to have an extra stage of correction that needs to be done. We'll talk about a mirror rig first off. So if you're shooting on a mirror rig, there are two things that you're going to have to do to the image straight away just to end up with your left eye and right eye correct. One is to correct the color cast, which will come from the use of the mirror, so one of the eyes will need color correcting. The other thing is a flip, because one of the images is going to be upside down. So that's specific to a mirror rig. Then there's a stage of technical correction. Now, technical correction is a case of vertical and horizontal alignment to make sure that the images are both lined up correctly over one another. If that isn't done, the resulting 3D could potentially be painful to watch, so it is something that needs to be done. The other stage of correction that would be necessary if you're using a parallel rig is convergence. Now, that's more of a creative correction than a technical correction. So that's an extra pass that will need to be considered if you are shooting parallel. The next thing is, how much correction are you going to do before offline editorial? Now, we would always recommend that in an offline cut that the editors are able to at least view some of the time the cut in 3D. Because from an editorial point of view, it's very important that you're able to watch the cut in 3D, as just working in 2D may not be sufficient. And you may find that when you view the cut back in 3D, that it doesn't work as well as you'd hoped. So we think it's very important that you're able to view in 3D and offline. Now you can see down at the bottom, we're talking about budget considerations. Now, obviously, if you're on a high budget feature, there's going to be a significant amount of money to perform these corrections, and you'll have, hopefully, a reasonable amount of time to do it. In television, and particularly the kind of things that we've worked on, budget is far more of a consideration. So you need to think of a way to manage the amount of correction that you have to do, because it's a time-consuming process and it's an expensive process. So you need to be able to manage the material somehow. So how we've dealt with this on the productions we've worked on so far is to go through a select process, much as you might do in 2D, just to make the amount of footage you have more manageable to sort through in the offline and to be able to deal with. We would recommend that you go through a select process to find the best takes, find the pieces of footage that you know you're going to want to look at, and just correct those. That's quite an important stage, because you can then end up with many hours of material down to hopefully a few tens of hours of material, and that will be far more manageable to correct. Okay, a very familiar phrase, fix it in post. We'd like to talk a little bit about what you can reliably fix in a stereo shoot and what you must get right on the day. The kind of things that you can reliably tweak after the event are things like convergence. You can make small convergence adjustments to shots and things like that. Assuming if you have worked on a shoot where you've shot converged, you can still tweak the convergence slightly. Obviously, if you've shot parallel, that's going to be a more significant amount of work. Kind of things you must get right on the day. If you've got bad geometric alignment, that kind of thing could be very expensive to fix if you're trying to go and do it after the event. So it really is paramount that you get as much of this correct on the shoot as you can. Other things that could be very difficult could be problems with set design and things like that. And I'll talk a little bit more about that later on, as will Marcus. But there are things that you can do on the shoot that you really won't be able to fix in post. Or you potentially could, but you'll be spending hours and hours and hours doing it, and you will use up all of your budget trying to do it. So these are things that you really must be very careful about. We'll talk very briefly about integrating CGI. We're going to show you two pieces very shortly, one of which has a very significant amount of CGI in it, which was a piece we made for Discovery Networks featuring Bear Grylls. And there's also a piece that we worked on for Samsung that we're going to show you as well, and that had a lot of comped CGI in it too. So you see here we're saying previs as a useful tool. If you're working on a set, on a stereo shoot, it's going to be too late and very expensive to suddenly discover in the middle of your shoot that you have too much depth in certain shots, that the way you wanted to set certain things up, the set is just not going to work. There's a number of previs tools out there. It can be very useful just to model the set beforehand, before you go and do the shoot. You can position cameras, you can figure out how much depth you're going to have. And that way you can hopefully get the set design right before you get onto the shoot. Following on the second point, I mean, this is essentially the same thing. Have an awareness of your set design and size, how the camera is going to fit within that, and how much depth you're going to have in the resulting shots. And again, briefly, just talk about compositing techniques. Again, Marcus will go into this a lot more when you've seen the two pieces that we're going to show you. But it's a case of what you can get away with, what will work, and what won't, and why. And there's a number of slightly esoteric things that you might think, yeah, that will work perfectly in 2D. You'll discover in 3D that it won't. One of the things that's commonly done in 2D is adding grain. Adding grain in 3D, if you add grain into two of the shots, you have to add the grain in a certain way, because otherwise you can end up with essentially a static 2D plane featuring the grain, and you will find you've literally got a plane of grain hovering in front of the images. So that has to be managed in a particular way. If you'd like to all put on your glasses, please, we're just going to show you the first of two pieces. The first piece we're going to show you is the Bear Grylls feature that we made for Discovery Networks.
Hey, so I think the first thing I want to quickly talk about is, like any job that comes into our facility, because it is a short-form job, we often have a limited budget and a limited time to deliver the final product. And both Samsung and Bear Grylls were no different. We had a very sharp learning curve about how to do stereoscopic production, which we worked closely with Vision 3 to do. But especially on Samsung, we had the main thing that you get with commercials is we had a very short amount of time with our actual talent. We had 10 minutes with those 3 footballers, and we had to capture all of their performances, get all the action, and in a very, very short space of time. And normally on a commercial shoot, you have at least the liberty of shooting with multiple cameras, and you can kind of redo stuff again, and you can change lenses quite quickly. But with these guys, we went to their training ground because they only had a certain amount of time. So we shot with 3 rigs at the same time, and the cameras never ever stopped rolling. So we had the added pressure when we came into post that we had an enormous amount of rushes to deal with. And we also had a client that was using this as a demonstration. So we had a lot of pressure on us to get it very right, and we had actual engineers from Samsung come in when we were doing the post to make sure that it was actually showing their television in the best way. But it was a very enjoyable experience because often doing visual effects, you have to do things that you've never done before, and clients and ourselves, Envy, really enjoy kind of pushing that boundary. But as being a 2D visual effects supervisor, there are lots of things that you can get away with in kind of doing 2D visual effects post. A lot of work that we do, as you probably know, a lot of excessive cleanup work, a lot of things when you get to the shoot, they're often like, oh, can you extend the set this way? Can you replace that? Can you change this? Etc., etc. So there are things that we have to deal with a lot. And in stereo, we were warned, and from an extensive R&D that we did, from kind of looking at what had come out of a features pipeline, from speaking to people that had come off Avatar and kind of other stereo features, that there was a big kind of gap in short form workload, like how much rotoscoping, how much paintwork you can actually achieve. And a lot of it seems to be you have to just try it and see if it works. So as a supervisor and advising clients on set under a pressured situation, we had to be very careful that we didn't say, oh yeah, we can fix it in post. Like 99% of the time we can. And nowadays the technology and the talent is out there to almost do anything. But in stereo, we found that the human brain is an incredible device which that you can't trick. You can trick it, but you can't trick it as well as you think when you get into a stereoscopic workspace. So I just want to show you some examples from Samsung of what we could do and what we couldn't do. So first I'm going to start with the negative, because I think it's always good to get that out of the way. We built a real football pitch for these players to play on because they wouldn't play on AstroTurf, and their coach wouldn't let us do that because we were in the middle of the season as well. So if you look here, we have the grass, because they'd been playing on it a lot, got very badly damaged in this section here. And the client on the set was quite adamant that we would try and fix that. And that's something that we actually couldn't do. We did extensive roto and paint reprojection and cleanup work to try and fix it. But what we ended up getting was these incredibly strange swirling patterns in the grass, which traditionally in 2D you would use a clone tool, or you would take some other pictures and you would replace the patches in the grass. But what we found is trying to do this in both eyes and to match the kind of the offset alignment was incredibly difficult. And the only way that we could find to do it was to rotoscope out the people, reproject a whole CG grass plate, and to do it. And for our client's budget, that was very, very restrictive. So that was something that we found across the board that is very hard to do, to basically do paint cleanup work on textures. We also found it on grainy walls or on roads, or something that has kind of multiple textures next to each other. If you try and paint and clean it up, it creates these incredibly off-putting swirling patterns, and your brain kind of sees it. But that was a surprise to me, to be honest. I thought that kind of paint and cleanup work we would be able to do.